So today our Stages mini partner workshop presenters are the Texas General Land Office. We have Josh Oyer joining us remotely, and Jason Pinchback will be joining us shortly in person. So I will hand it over to you, Josh, to get us started.
Yeah, hi. Good early afternoon, everyone. As Audrey said, my name is Josh Oyer. I work with the Texas General Land Office in the Coastal Protection Division, and Jason's in the same division. My main role is in developing and implementing the Texas Coastal Resiliency Master Plan, which I'll give some more information on here in a second. Just want to make sure before I get started, you see my slide, making sure my slides advance on the screen. Is that looking good? Mm-hmm. Yes, okay, and you can hear and see me all right? Okay. All right, everyone. So as I mentioned, with the Texas General Land Office, just want to give a quick overview of the agency, since I know that you all are interacting with a lot of different state agencies, and there are so many different state agencies in Texas doing work along the coast and fulfilling different facets of responsibility for the state in the coastal area. So I just kind of want to give pretty general overview and background of what the GLO does for the state. And so, the Texas General Land Office is a very old agency. It was established in 1836 by the Republic of Texas to basically keep land surveying records and land deed title records for the Republic of Texas. And of course, since then, the agency has grown quite a bit. We have many different responsibilities. Of course, I'm going to talk here in a second more about the Coastal Protection Division, but just to give another bit of background on some of the other divisions we have. Of course, I mentioned the archives and records role we have. We act as a fiduciary to the state, so we manage state lands across the state in the coastal zone, and as a part of that, as being in the role of being a fiduciary, the agency manages state lands and issues leases on state lands for many different activities, including energy development, and then the revenues that are generated by those leases go into the permanent school fund to fund different things related to education in Texas. So there's a pretty central role there that the GLO has. We are also home to the Veterans Land Board, and we have a very large disaster recovery division, which allocates funding from the U.S. Department of Housing and Urban Development related to disaster recovery and disaster mitigation. So some of you all may have heard of our CDR division and some of those projects going on. But let's dig in a bit more to the Coastal Protection Division. And we continue this role as a manager of state lands and a fiduciary to the state in our management of submerged lands in the coastal area. So that's anything under tidal influence out into 10 miles into the Gulf of Mexico. So that's quite a bit of submerged land there. And you can see there in the map on the left, that's a general map of the way we've split the coast up into regions, and you can see the inland extent of that Texas Coastal Zone Management Area, and you can see the extent that it goes into the Gulf of Mexico. Of course, those regional call-out boxes don't count, but I think you can generally see the coastal zone boundary there. So through the Field Operations Division or wing of the Coastal Protection Division, we do these leasing activities and managing those submerged land tracts. Under the Resource Management wing of the division, we have regulatory responsibilities relating to the Open Beaches and Dune Protection Acts, and that's basically to maintain and ensure the protective capacity of our dune system on Gulf-facing beaches, as well as maintaining access for the public to our beaches. Again, Gulf-facing environments in those regards. Under resource management, we also have the Adopt a Beach program, which organizes volunteer beach cleanup activities across the coast. We also have our work in the Water Resources Division, which Jason will get into more when he gets here, but the Adopt a Beach program, the Texas Beach Watch program is pretty central to the Water Resources program, in that they monitor bacteria levels at recreational beaches to issue advisories when those levels exceed the level that's advisable for contact recreation. They also have the TAMUCC program, so that's the tide gauge program across the Texas Gulf Coast. And then under the funding programs, we have a couple different funding programs. One is a state-funded erosion program known as CEPRA that you might have heard of before. Do a lot of beach nourishment, a lot of marsh restoration, shoreline stabilization type projects, as well as the coastal management program, and that is a partnership with NOAA that allows us, and I'll get into more of it here at the end of this PowerPoint, but it allows us certain roles and responsibilities that interact with the federal side of things, but also issues about $2 million annually in grants. And then, of course, oil spill prevention and response. That wing of the division is hopefully pretty self-explanatory. They're trying to prevent oil spills, but then respond to them once they do occur. And then under the planning side of the Coastal Protection Division, that's kind of where me and a couple colleagues work. That's kind of to tie a lot of these priorities together, given we've got very different types of roles across the division, and we seek to kind of tie all that together to work towards providing a platform to speak to the types of priorities that we pursue as a division, including the fact that we have either the 6th or 7th longest coastline in the nation, depending on how you're measuring that, versus Gulf shoreline versus the total bay shoreline miles. Very large coastline in Texas. We've also got kind of, in terms of talking about the need for a plan and the need for a planning team, we've got, of course, the bad news and the good news across the coast that drive the need for a plan. The bad news we've probably heard too much about, but breaking all the wrong kinds of records with the size of the oil spill in the Deepwater Horizon, as well as the rainfall totals, and 2017 Hurricane Harvey, and then 2020 hurricane season saw a record broken of the most named storms, record of 30. So having a lot of continual threats along our coast and changing conditions driving the need to understand where our highest priorities are laying. In addition to that, we've got some good news. A lot more funding has come online in recent years. So we have a need to kind of help prioritize our internal funding decisions at the GLO. We've also got a number of funding sources external that are informed by our planning activities, namely with the Restore Act funding, the National Fish and Wildlife Foundation, and other sources. We've also recently had some successes in the 2019 legislative session with a hotel occupancy tax bill that allots additional funding from that hotel occupancy tax that's collected from visitors to hotels in coastal communities. And more of that is now going into our Coastal Erosion Planning and Response Act program that I mentioned. So we've got more money to address those issues. And then our GOMESA funding, which is funds that are shared by the federal government, by the Bureau of Offshore Energy Management. Those are funds in federal waters that are revenues from oil exploration and extraction that are shared to all Gulf states, but we get a large portion of those, and we supplement the funding of our CEPRA and CMP programs with the GOMESA funds. So we've got some good news. It's still not enough, but have more funding than we traditionally have had in years past. So this kind of leads me to explaining the Texas Coastal Resiliency Master Plan. Again, I'm the manager of this effort. Essentially, what the Texas Coastal Resiliency Master Plan is it is our state-led, ongoing, and long-term coastal planning effort for Texas that works to identify and provide a vision to protect our coastal communities, habitats, and infrastructure. So it's doing this through multiple lines of defense approach that it recommends nature-based traditional infrastructure improvement ideas and programmatic measures as well. And it identifies tier 1 projects that our agency can invest in, and our programs use that as a list to help drive their recommendations for funding. So as I mentioned, it's an iterative process. So we just released the most recent version of the plan in 2023, and that builds on the iterations from 2017 and 2019. And of course, this is due to the changing conditions along the coast, and the evolving preferences of our citizens. And so we see about a 4 to 5 year planning horizon before the next plan is issued as an appropriate time frame to allow projects to be implemented and for us to understand the way some of these projects are interacting with the conditions along the coast. So I'd love to use a good metaphor when describing anything, but if I can describe the resiliency master plan in a metaphor, I view it as an incubator, a platform, and a funnel. The incubator is working with our stakeholders on the technical advisory committee to collaborate between and among them on which projects we can promote, and we build consensus through that incubator. The platform is speaking to the value of investing in the coast, and we're trying to speak to state and national audiences, including our own state legislature. And then we also use our platform to communicate which opportunities we need to capitalize on. And then the funnel helps us justify and direct funding to those opportunities. So since there are so many different types of approaches taken by various state and federal agencies when they put together their strategic plans, we think it's very beneficial to be very explicit in the role of this actual plan. Again, since there is kind of a different approach taken with different planning efforts across the state. So this plan, to be quite clear, it's basically a snapshot in time of the needs of a snapshot in time of the needs, coastal needs for our state at the time of publication. So it's an opportunity within this snapshot in time to show our alignment with our stakeholders' priorities and other experts. This plan is not an automatic funding mechanism. However, the Tier 1 projects that are prioritized in the plan are typically looked at very favorably for our funding sources. So there's no guarantee that projects will be funded. The partners still need to apply through whichever funding source they're seeking. And it's also not completely comprehensive in that we're working to kind of fill in some of the gaps of the large scale federal mega projects that are ongoing through the U.S. Army Corps of Engineers, as well as some of the state flood planning through the Texas Water Development Board. And so just to give you an idea of kind of how our framework works to inform each planning process, this framework kind of depicts how background conditions, economic, social, natural drivers result in human-induced and natural processes that exert pressures on our environment that result in vulnerabilities that we can essentially we can observe, we can measure, we can monitor them, and those are grouped into the categories of land change, flooding, and degraded water resources. And so through a process of interacting with our technical advisory committee and getting their input and evaluation on our process, as well as taking different types of data and working with consultants to analyze and create new types of data, we arrive at an understanding in the blue box there of the state of our coast. So what's the state of our society, our ecology, our economy? And then from there, we look to derive wide scale and long-term actions that our state can be investing in, and then applying different strategies, we arrive at that Tier 1 of the list of individual projects that work to implement the larger and wider visions of action that we need to be implementing. And then looking at the feedback arrows there, we continue to go through a process of monitoring and adaptive management to feed into our understanding of the vulnerabilities in the state of the coast. Looking just a bit closer at those vulnerabilities that we are attempting to confront with the Texas Coastal Resiliency Master Plan, they are looped into the categories land change, flooding, and degraded water resources. And these are essentially vulnerabilities that are within the purview of our agency, and most especially our Coastal Protection Division. And so through our lens, we're attempting to understand how a change in one vulnerability leads to potentially a change in another vulnerability, and looking at the interconnectedness of our coastal system, and then attempting to encourage projects that implement more than one action or have multiple benefits, provide multiple ecosystem services that support society, support our ecology, and have other benefits for our cultural needs as well. looking a little deeper just to give you some insight into the types of data that we're actually generating with our planning process. We're working there with Dr. James Jabot and his team there at the Heart Research Institute. I see you're all sitting there in a familiar room. And so they've been working with us since the beginning of this planning effort and have been modeling for future conditions along the coast using the NOAA sea level rise report that leverages 3 different sea level rise scenarios on a global level, and then using those scenarios and running them through the sea level affecting marshes model, we arrive at an understanding of relative sea level rise along the Texas coast in the intermediate low, intermediate, and intermediate high scenarios. And that's a half meter rise, 1 meter rise, and a 1.5 meter rise to the year 2100. And then we're able to look at different potential phenomenons such as land loss and open water conversion, landscape change, and see how the marsh migration corridors and the open water conversion potentially leads to increased storm surges across the Gulf Coast. And then we tie all that together into geohazard maps that are helpful for community planning and project conceptualization. And just to give a bit more of a plug on this data and where you can find it, you can find our modeling data viewer there at the URL provided at the bottom of that slide at www.glo.texas.gov/CRMP. And hopefully that's memorable as Coastal Resiliency Master Plan. But I know everyone in this room is more technically familiar with the way these map viewers work and the way GIS works than maybe some of our other audiences that we speak to. So I don't have to go too far into the capabilities of some of these types of map viewers. But of course, you can search by any type of location in the search box. You can choose your sea level rise scenario, look at the different landscapes, use the slider bar to see how we're anticipating to see those changes into the year 2100. And then there's a downloads capability there. You can pull the data directly, and then you can actually view the tier 1 projects in that as well. Just to look at more tools and communication devices that we have on our website there, same URL. You can find all the documents related to the life of the plan, story map, and of course that modeling data viewer. And then there are some really helpful resiliency project design guides. There are 8 of them, including the funding one. And you can take a look at the way that we are informing our stakeholders on the different steps that have to be undertaken to implement a project. And you can kind of see some of those design considerations for a more resilient project moving forward. And then before I just talk briefly on the CMP program, just want to see, did Jason make it into the room yet?
He's here.
Okay,
Yes.
great. Okay, great. So before I transition over to Jason, just want to give you all a quick overview of our CMP program. And this program has been enabling the Texas General Land Office to be a partner to NOAA through the Coastal Zone Management Act since the 90s. So it's been around a while. And the program has kind of 3 parts to it. One is, I mentioned those grants that they're administering down to different applicants across the Texas coast. Those funds come from NOAA directly. We also administer projects of special merit through the CMP program, and those are funded through GOMESA. So a little bit different scope of project there, and different goal of each proposal there. The CMP program also participates in consistency review, so they're reviewing various types of large-scale permit applications to make sure they're consistent with the goals and policies of the coastal management program. And then they're providing permit assistance to individual small businesses and local communities through different types of technical assistance there. So they're fulfilling a large niche for the state of Texas by way of the Texas General Land Office as the partner. So definitely around the rest of the meeting to answer any questions, or I don't know if y'all want to dive into that, but I think Jason's probably ready to go to speak about his stuff. But so I'm just standing by to answer any questions or dive into discussion whenever is appropriate. Thank you.
Thank you, Josh. Before we hand it over to Jason, Jason's here now, I'd like to go around the room and our online participants. And if you can give a quick introduction, who you are, what organization you're with. So we'll start in the room. Mandy?
I'm Mandy. I'm a master's student in the chemistry department here.
Hi, everyone. I'm Mahima. I'm a master's student in the marine biology department.
Hi, I'm Allison. I'm a PhD student in coastal and marine system sciences.
Hello, I'm Justin. I am also a PhD student in the Coastal Marine System Sciences.
Hi, my name is Quincy. I'm a master's student in the Coastal Marine Systems Science program.
Hi, I'm Philip Tissot. I'm the chair for coastal artificial intelligence at the Conrad Lucher Institute and one of the faculty working with the students here on the NRP stages.
I'm Remy. I'm a master's student in the chemistry program.
I'm Laura. I'm a master's student in the Coastal Marine System Science program.
Hi, I'm Ifeanyi. I'm a PhD student in the same program.
I'm Blair Sturba Boatwright. I'm Emeritus Professor of Mathematics and Statistics participating in the program.
Hi, my name is Roya Narimani. I'm a postdoctoral research associate and I'm working with Dr. Dorina Morgolets.
And I am Dorina, and I'm one of the faculty leading this program and directing the Center for Water Supply Studies. And Roya will be part of this program as she takes a little bit more of the computational responsibility teaching from Dr. Tissot starting this summer. So she'll be deeply involved. Online?
Online?
Leslie Hartman, Texas Parks and Wildlife Coastal Fisheries up here in Matagorda Bay.
Lucy
Hi.
Flores
Sorry, you go ahead.
with Jason in Water Resources.
Hi, I'm Yazhuan Ling. I'm an assistant professor in life sciences. I'm a biological oceanographer.
Patrick Nye, I'm president of Ingersoll the Bay Coastal Watch Association.
Hi, I'm Bea DeBona. I'm a PhD student in the marine biology program and also a part of Stages.
If Lucy introduced herself, I think somebody cut her off.
Lucy, could you go again? You were cut off earlier.
Sure. I'm Lucy Flores and I am the Texas Beach Watch project manager and I work under Jason's leadership on the Water Resources team at the GLO.
And Kayla?
Hi, my name's Kayla. I'm a master's student in marine biology.
So we're ready for you. Patrick or Jason.
Hey, good afternoon. All right, so they. Are we awake? Good afternoon. Now, look, we all have different, our best, right? So let me just confess to you, I'm going to start like I was raised Catholic. I'm not Catholic anymore. I'm coming to confession. If I look sane right now, it's kind of a facade. I'm a little, it's been a Monday, like many times over. So I apologize for my tardiness here. But I also want to say, I'm going to ask for your grace. And this presentation I'm doing today is more going to be like insights and methods and how we're looking at coastal interactions, coastal water quality. I'm going to try to pull from some different things on my computer. It's going to be a little clunky, so just have a little patience. And I also want to just ask for you to take a pause. And allow your mind to drift into thinking about water. And I'll have different connections with water. Water means connections to all of them are different places. Give yourself just a second to go there mentally. Want to strategically pause on this idea and thought, because our minds are in a million different places. I could ask any one of you right now, there's probably a Ferris wheel of things like my brain. You're thinking about all kinds of stuff. As a cat fan, where's the dog, boyfriend, girlfriend, and whatnot. It's all going on there. We're just going to take a pause and think about water. While we're listening to this, I'm going to share just a little bit of my background because it helps to form of how I got here in front of you today. I started as a citizen water quality scientist as a high schooler. I was fortunate to go to high school. So we were out collecting data with YSA songs like a million years ago. I brought my passions to bear through college, got a master's in master's applied geography. So my world, I see it through the lens of a geographer in many different ways, but we're talking water. I worked at Lower Colorado River Authority for about 5 years, doing water quality work, supporting citizen scientists, doing pollution response. I then worked at Texas State University for 12 years as part of the River Systems Institute, working to advocate for a lot of different water quality issues. And I've been at the General Land Office for around 13 years now, working on a variety of things, but my heart is in water. And our water resources programming, it includes, Lucy Flores mentioned a minute ago, Texas Beach Watch, something called Texas Coastal Ocean Observation Network, or TCONS, platforms in the Gulf measuring a lot of different environmental data, including tidal changes, as well as the state's Coastal Non-Point Source Program, which is how do we better manage non-point source pollution. And so my goal here today is to kind of go big picture in the coastal zone, talk real big picture. We're going to talk a lot of land use stats. We're going to talk about land use. We're going to drill that down into the big question, or maybe a couple of questions we tee up as you consider your projects of interest. So I've tried to root myself in some of the classic Stoics as to give me indications of where I need to be focusing my mind. So I thought this was a great one. Let's just say no person ever steps in the same river twice, or it's not the same river, and that person is not the same either. And so I adopted that a little bit for the context of our discussion today, which is no person, business agency, or local government lives, plays, and does business in the same coastal community twice, as this area is constantly changing and we are constantly changing. So a big piece of the question we're going to eventually get into is what is driving some of the changes and what are the confounding variables coming to bear that, quite frankly, it's a mystery if you're into water quality and answering the whodunit. So we're going to start with kind of big picture stuff. Around 30 years ago, the General Land Office and other networked agencies, they got together and they're like, what is the area of land use that impacts coastal water resources? And so from that was a big discussion. It was both science as well as political. And this boundary right here, or line, was identified and depicted. It's this dashed line. This is around, we'll see some stats. It's around 14,000 square miles, or 9 million acres. That's water and land. And if you look at some of the population stats, quite a few folks are living in the cities. And so this, what we've heard about migration from rural areas into larger cities, that's been happening in the coastal zone. It's demonstrated in a number of different instances through census data. So now we're turning to look at impervious data, impervious cover. So what's impervious? Impervious is like a driveway, a road, a roof. When it lands on it, it doesn't percolate in. It washes off down into the road, down into the ditch, then into a stream, and then into our bay or estuary, where we rely on that area to be strong for fisheries, strong for recreation, industry, and many other purposes. MA is short for management area. That's coastal zone boundary. I'll try not to throw too many acronyms at you. But when we look at the big numbers for impervious cover, a theme that I'm going to share with you today is when you look at an average of this impervious cover, it's very insignificant compared to what we see in many other populated areas. So one of the larger ones, Cameron County, 5%, but this is 0.4, 0.2, 0.5, Nueces, 9%, 3%. So what this is saying is that the land mass within these counties in the coastal zone, that percentage of the land mass is impervious cover. And we're going to get around to why we talk about impervious cover and what the implications are. But as you look around, some of it might be hard to read. I am up close so I can see it. 2%, 1%, 0.5, 0.7, 3 in Brazoria, 12 in the Harris County area. They've incorporated some of Galveston there as well, 2%, 7, and 6. These are relatively low impervious covers when we talk about the land mass. Let's look at water resources. We know water's everywhere, surrounded by, it seems limitless. 12 major rivers in the coastal zone, 152 named bayous, creeks, rivers, bays, and estuaries, almost 5,000 miles of rivers and streams, and quite a bit of monitoring occurring in the coastal zone as well. As we switch to look at wetlands, the green color here is identified as wetland data. All of these numbers I'm sharing, they're about 6 years old or so. They're not exactly up to date, but these give us insights and indications. A lot of wetland resources. Of course, many of these areas are in transition as well. Okay, so this one, when we collected this information, it was pretty darn astounding. When you look at the landmass at large and you look at the protected areas, and we're going to look at a stat in a second. We'll just review what these are. So some of these, like Padre Island National Seashore, these are included with our beaches. They're protected zones as well for no development. These are areas where there's conservation easements. This is even like the local park. There might be a ball field or something, or baseball or something along those lines. So both private as well as public entities. But when you look at the percentage of the land that's covered within a protected easement of some kind, protected area as a percent of the total land, 39% of the coastal zone landmass is captured within some type of a protected area. I don't know about you guys, but when I first saw that, and we were doing the GIS to put these layers together and doing the analysis, I was quite blown away. It almost seems unfathomable in the way, but there's a series of circumstances that have come together, including a lot of people working together in collaboration and partnership to make this happen as well, such as the purchase of regional refuges, et cetera, both through TPWD, Ducks Unlimited, US Fish, GLO, TCEQ, TPW. Anyways, it's a long list of folks working together, but this is quite extraordinary. You're going to see a term, you've already seen it once, I haven't really explained it, MS4 and non-MS4. MS4 is a regulatory term that TCEQ has delineated a threshold of population. Once you exceed this threshold, you need to have more stormwater enhancement, additional stormwater regulations so that they're treating the stormwater on site. And then the smallest, so Corpus is definitely MS4, some of the smaller cities, such as Centon, Kingsville, I doubt is, but it could be. It's the smaller towns that are non-MS4. And so there's a different regulatory environment from city to city and across from the larger towns and the city towns, the small towns and the larger towns. I told you I can be a little crazy, so it's just going to happen. Here are the big numbers, around 9 million acres and 14,000 square miles that are encompassed within that area. So now let's look at the land use types. This is from the National Land Use Land Cover Database. And so each of these squares going back to the land mass is around 4.5 million acres. So each of these squares is accounted for 4,789 acres itself. And you start to look at a breakdown of what we have. And so this mimics in many ways the developed area versus all the other categories, mimics some of the other data that we were seeing there. So we see some commonalities. But if you stay in Corpus, you don't necessarily, if you don't leave town much, you don't necessarily get that hint unless you start driving out towards Kingsville, down 77, or as soon as you leave town heading up towards San Antonio, there's a bunch of cropland in undeveloped areas. But then the big grand finale of the land use is, okay, what are we seeing here when we look at undeveloped versus developed? So around 13% of the land mass in the coastal zone is developed. And so the coastal zone is very unique, but from upland studies, we can look at how watershed functions change with land use. And so there are many different studies, but they show some commonalities, and the commonality is this: when impervious cover percentages in a specific watershed start to exceed 12, 13, 14, 15% impervious cover, not just developed, it's impervious. These are the hard surfaces where there's no infiltration. Watershed functions decrease substantially. Biomimicry decreases substantially. Ecosystem services decrease. And what that means is this balanced equation that exists when you have moderate development and you still have open lands. These functions still occur in somewhat of a natural way, although they're altered. But when they shift past that number, then we have to be in a position, you have to engineer your way out of these problems. And so a theme for my discussion today, that one of the walkaway messages is, yes, there's a lot of development going on right now, but when you look at these numbers, you fast forward one generation, 25 years. What is this going to look like in 25 years? Where's this red going to be? Is it going to be here, 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 here? How about 50 years? Where's that red going to be? So in the grand time scale of a sense of place for where we are as individuals, as learning practitioners, how do we apply ourselves? A big challenge, quite frankly, for you all and all of us as a community of watershed practitioners is how are we going to make better decisions as we grow? Because the growth is happening. It's going to happen no matter what. And all of our leaders, we all want economic prosperity. We want to have opportunities. We want to have amenities. We want to have fun. We have a big quality of life. But over time, this indeed is going to move over. And so our challenge to ourselves right now is how can we reimagine how we interact with the land as we develop? So just a couple snapshots kind of proving and illustrating that point as we look at Port Lavaca. And then here around the Corpus Christi area, where's all the growth happening around Corpus right now? Where's it going on? Anybody know? It's definitely expanding out. Is it coming out this way?
Flower Bluff, really.
Yeah, down here, Flower Bluff, yeah.
Both South Side and Ingleside and
Yeah, I
North
saw
Shore of the bay, San Patricio.
big developments, part of like farm roads on the south side.
So Corpus is experiencing this right now. I was at a county commissioner meeting a couple months back. And people making comments were talking about this envelope outside the city jurisdiction where it's county jurisdiction and the difference in ordinance and some of the pressures about delivering services to these folks. So it's on right now. Okay, so we talked about water resources. This is a snapshot from the TCQ data viewer. Anybody can gain access to this one here. And it basically, blue lines illustrate our water resources as identified and delineated by the TCQ. And then we have overlaid on top of that, the red lines indicate that there's some type of an impairment on a water body. The one that encompasses the Gulf there is likely fish tissue. Maybe it's elevated mercury. Let me see if I have the next slide. Aha, there it is. So when we look at a breakdown of what the impairments look like, a significant portion are impaired due to contact recreation or elevated bacteria, aquatic life, depressed or low dissolved oxygen. And then we have fish consumption advisories, mercury dioxide, et cetera. And then oyster waters in different areas are impaired. So we're going to spend a lot of time. We're going to start drilling into this contact recreation question here through the eyes of Texas Beach Watch. So let me just pause there. And as we kind of change chapters, any questions, points of interest, comments? Yes, sir.
Last one question. That was pretty amazing, the 40% of the land protected. Is it at the right place, and more specifically the wetlands? Do we have enough protected areas in the wetlands itself? So the 40% is awesome. I didn't know.
It's incredible to see.
Yeah.
when you look at transitional wetlands, they're transitioning pretty quickly.
Yeah.
Many of the wetlands are on private property, so this is just related to private property acquisition, development, creation of new amenities. And so these are track by track. I would just venture a general statement that enhancing the protection of wetlands in areas where they can be prioritized is important. Much of the large acquisitions are based on, in many cases, the habitat that serves multiple species, often with birding related endangered species driving the way for some of the bigger acquisitions that occur through state cooperative and NGOs such as Ducks Unlimited. Anybody heard of Texas Beach Watch? See if you like the beach. Yeah, I know you've heard of it a time or two. So Beach Watch, it's a really cool program. This is a snapshot of the data viewer that we have online, texasbeachwatch.com. So Beach Watch program, it collects data from 172 locations across the Gulf of Mexico, from down near the mouth of the Rio Grande, all the way up to Sea Rim State Park in Jefferson County. These sites are monitored weekly during peak use periods, and then bi-weekly over the winter months. We use it's called a fecal indicator bacteria. So it is called Enterococcus. And when Enterococcus is present based on epidemiological data and findings, then it indicates the presence of other viruses and bacteria that are harmful to human contact. And so it is the indicator that we are using. Our program is operated using the guidance of EPA, and there are beach watch programs across the United States. There are many of them everywhere there's a coast, at least operating these programs with Coastal Management Program. We collect a sample in a little bitty bottle about that big, 125 mils. Take it to a laboratory, incubate it, and if the colony count after it's incubated is greater than 104 colony forming units per 100 milliliter, then a beach advisory is posted, and we coordinate with the local government to post those advisories. So when they exceed the acceptable standard, the advisories are posted. We do not close beaches. And in Texas, we give you the information and let you make the decision, okay? And so often, if there's an advisory in one location, you know the beach, you can look at the map, you can go down here. Maybe there won't be an advisory here, which is often the case in any Gulf beach, or you can go over here and there won't be advisory over here in another adjacent location. Or you can choose to go right there. Each year, it varies, but there's going to be more than 7,000 samples collected just as a part of the routine sampling. And we have around 42 sampling events, so we have a very robust data set, but this is on schedule. When an advisory is posted, the field staff go back out to that monitoring location and collect another sample and then analyze that again. And if it's below the threshold, the advisory is lifted. So it goes from the bright orange big sign, it collapses down to just the light blue sign. And that's how we notify. We also have listservs. You can sign up for notifications and you can look at the website. And then there's some private groups who help to disperse the information as well. And a few years back, we co-published a long-term water quality study with a PhD candidate at the time, Nicole Powers, and our team. We published a study under the Marine Pollution Bulletin looking at long-term water quality analysis. So prior to that, we were just, the program had been sitting on this gold bar treasure trove of data that had yet to be tapped. And so when we reorganized and we formed this new team about 7-8 years ago, one of the first things I was like, we need to get an understanding of what are the long-term trends going on across the coast. So let me explain what we're looking at here. A minute ago, I told you what an advisory is. So what we're looking at is aggregate number of advisories in a county. So when the title says 10-year action value beach exceedance summary. So this is a compilation of around 90,000 sample events. These are aggregated by county and they're specific to the percent exceedances. we'll talk about why these are important in a sec. Couple things up here pretty quickly. We have bookends with Cameron County as well as Jefferson County over that 10-year period, demonstrating exceptionally good water quality with low bacteria, with low exceedance rates. And then as we look everywhere in between, it's a little bit of a mixed bag. And you see there's a combination of, let's just call it the good, the bad, and the ugly, in which there are some areas with higher exceedances here. For those local to Corpus, do y'all know there's a particular area? Okay. Is there a particular area that who's had some long-term water quality problems here? Yes, ma'am. Oso Bay's been, yeah, they have some plans working on Oso Bay. There's another one as well, one other area. And I know Philippe knows this area. There's several sites in and around Corpus Christi Bay. Cole
Park.
Coles Park, yeah. So there's several parks there that have some long-term issues with water quality. But countywide, we see what we're looking at as these aggregate values are presented. Okay, so trends over time. What is going on with the trends over? This is a key question if you're interested in what does our future look like. And that study identified increasing levels of bacteria over time that were correlated with population growth and sea level rise. And so basically what it said was there's been a trend that was statistically significant. It wasn't one of these, it wasn't a mark like this where the line wasn't like this. The line was kind of like that, fairly small slope, but it's showing increasing trends over time. So I get the opportunity and privilege to serve coastal communities. And in one of the mechanisms I use to serve the communities is to talk and to listen. And so me and a colleague, we held a number of, let's just call them informal one-on-ones as a survey mechanism. We were talking about non-point source pollution and water quality was our driver. So know that was the context for these notes. This is from a, what is it called when you feed all your notes into a program and it gives you, is this word cloud? Thank you. This is a word cloud. And so what was in the notes more often is highlighted here as larger and maybe darker too, but at least larger. And what you see a lot of here is things surrounding bacteria and waste treatment. OSSF, those are septic systems, wastewater treatment plants, of course, development, drainage issues, bacteria, hurricane recovery is in there, always important. Excessive nutrient loading, wastewater treatment plant methods, runoff, pet waste, on and on and on. So these are very important to local decision makers and leaders in communities. Anybody want to take a guess as one of the big things we hear as to why it's important for a community that relies on ecotourism? Because when those beach advisories are flipped open, sometimes it chases people out of town. And a couple of communities are very vocal about what these advisories do and what people do and respond to these, because none of us go swimming at the beach with the idea of needing a shot of penicillin the following week. And so we have many different driving forces that are coalescing together that helped us form a mission at the General Land Office and our Water Resources Program. Is we have a main goal right now, which is to reduce beach advisories through reducing bacterial loading. And so that is a major initiative that we're full in on. I'll talk a little bit about our studies if we have time, but these impact local communities and their tax base. There's something called hotel occupancy tax. Of course, when you have a visitor who drives all the way down to Corpus Christi to go swimming, you stay in a hotel, you're eating dinner, you're buying the beach pass, you're going out, you're getting your drinks and your ice and your gas, all that stuff contributes to the economy. There's a lot of other reasons too, right? We don't want to get sick. We want to be suitable for the critters. We want to have oysters and shellfish that we can consume. That list goes on and on and on and on and on. So there's so many reasons where we all intersect together under the same goal, but we have a lot of different reasons as to why we intersect there. And that's where really we're trying to work and we're trying to live inside of that intersection there as there's so many people who want to work together. Okay, so we're drilling down, right? We're drilling down. Now we're gonna look at some specific data. I have to, of course, acknowledge this is one of our projects that Lucy and I have been working on. And in this presentation here, we have a lunch and learn series. It's online. It's about once a month. Dr. Morgulette has been featured on it twice. We've had Dr. Wetz, and this is from last week. Dr. Gabriele Benanti out of Texas A&M College Station. And so he was leading some of our desktop data analytics. So I'm going to share some more data about our contact recreation data. This is specific to Enterococcus, which is an indicator of other viruses and negative things that are biologically in the water that are going to be impacting us as folks who contact recreate. So a second ago, I presented aggregate 10-year aggregate data by county. So that was everything was piled into one little dot. So now we're gonna dig in one deeper layer. So let's see what we're looking at. These are percents of exceedances. This is also a 10-year data set. This actually might be 12-year data set. Yeah, I have to make sure I'm saying the right things, long-term data analysis. And so what this is showing is, and this is using the same classification of low, medium, and high. And actually, let me explain that real quick of what that is and why it's important. So, often when you look at data, sometimes you have a threshold that you know you're going to use, but what do you do when you don't have a threshold?
Do you make one based on the data that you're given?
Boom! Man, if I wish I would have brought some some kudo gifts or something. Bam! That was nasty. She said, will you say that one more time?
Yeah, you make one based off of what you have to create a baseline.
Yeah, you make it based off the data. And sometimes you don't know what exactly kind of a threshold you're going to make, but you look at the data and you ask the data. That's the coolest thing about big data is you get to ask the data questions like as though you're having a conversation with a person. Of course, it's a mysterious person who often you have to wrangle a bead up and twist it up into pretzels and squeeze it to get the answers out that you want and then to apply the correct techniques. But that's what we did here is we asked the data, and this is the way the data was best segregating itself. Now, let me tell you, there is a threshold that is established as percent exceedance. The state of Texas, under the leadership of the Texas Commission on Environmental Quality, establishes water quality standards that identify if a water body is suitable for its designated use. We talked about that earlier. We looked at the impairments in the red map. We saw that at that time, there were 78 impairments due to bacteria. They have standards for drinking water quality, pH, on and on and on, standards everywhere. So the state of Texas, TCEQ, has identified a threshold based on percent exceedance over a 5 to 7 year period of time of 25%. So there is a specific standard for contact recreation in our coastal waters along the beaches that we monitor, which is 25%. Now, for the state's purposes, for how they operate in a regulatory framework that is suitable for that state and how they are managing water resources. We're talking about the Gulf of Mexico, a Gulf-facing beach, high energy, massive energy, major dilution, nearly limitless volume. I imagine some folks have probably calculated these volumes, but we're talking Gulf of Mexico, not a bay or an estuary. Massive dilution factor, huge movement, lots of energy, limitless volume. So if you think about 1 in 4 times of going to the beach, of having excessive bacteria be above the threshold, that is a indicator that there are some potential problems and issues going on. If we collect 125 mil little bitty old sample. But we have concentrations that are so high and dense that we are exceeding that 1 out of every 4. For me, as a water quality practitioner, that is raising alarm bells, in particular the Gulf beaches. Bay beaches are a little bit different. Gulf beaches, this energy is insane. So the thresholds here, you're going to see these in a minute. And so now we can relate back to these thresholds. Basically, everything's pretty darn good. These are pretty conservative thresholds here for these high, medium, and low categories. So this is just for understanding systems. This is not a regulatory set of data, obviously. You're going to see a different picture as we move through these other counties here. So excellent water quality down here. Interesting, that lower section is down near the mouth of the Rio Grande on Boca Chica.
Is it on the Gulf side or is it on the bay side? Because the at South Spider Island makes total sense. You got the yellows on the bay side, you got the greens on the Gulf of Mexico, but I didn't know about the ones at Boca Chica.
Yeah, it's kind of interesting how it's crept up into that middle, but again, this is a very low threshold. Those are all Gulf side.
Gulf side.
And it's near the mouth of the Rio Grande as well. Boca Chica, there's not much land use going on. It's pretty undeveloped. This would be all pre-SpaceX data, not that they're impacting bacteria at all. There is one that's kind of on the Gulf side here, I mean on Bay side, but it's near a channel right there. And so, okay, so now we're here in our county, a little bit different picture as you see the conglomeration of data. Gulf side's looking pretty decent. Some of the Bayside activity, certainly of interest. Then you see Rockport up top. When we look at Matagorda County, in Brazoria as well, it's pretty interesting look here. Again, using the same set of thresholds across the map.
Got a question.
Yes.
For that one, in your study, what was driving that in this specific region? Do you have any idea?
That's what we're here to talk about.
Okay.
And that's a great question. What is driving it? And we're gonna talk a lot about it because this is one thing that I've been working with Dr. Morgalet on, and she has brought some very interesting insights. But this is truly a series of questions that are confounding and beyond a set of complexity that has allowed us to apply watershed practitioner principles and data analytic principles that might work in other areas upland in a stream or an upland river or lake that simply are not bringing the results that we'd like to see as in answers and what are the driving forces.
Patrick also has a question.
Oh, yes.
Online.
Could you go back to the Corpus Christi area map? There we go. I don't see any data points from Portland through Ingleside and Aransas Pass. Are those contemplated in the future, or how will that be addressed?
That's a great question. So with Texas Beach Watch is a program using the guidance is, let me just say this. We would like to monitor everywhere someone is recreating in the water. Those are our desires. We all desire a lot of things, and we can't do them all. And so often you're in a position of having to prioritize. So a number of years ago, a determination was made that sampling was going to be occurring at what's called a Tier 1 beach, and that's the EPA designation for a peak use beach. And so these sample sites reflect where peak visitation is occurring, and it's perfect timing on the question. As we're actually working with the team here out of HRI, they're in the final stages. We are updating our survey to see where people are recreating today. And that we intend to utilize that information to identify and potentially change monitoring locations pending where the activity is occurring. And the biggest thing that we have to look for is the impact to fiscal resources and how to manage a program in perpetuity in a way that it can be conducted over time. And so we don't want to just go in and hit a spot for a couple of months or whatever, then quit and then move to another one. As there's a lot of moving pieces to the network, but we do have interest in expanding the sites. Is that
Yes,
sufficient?
thank you. Yeah, I could add something. I know that you're looking at a lot of different factors, but we have a water sonde in Ingleside on the Bay that's measuring pH, salinity, oxygen, turbidity, and some sea level movement. I don't think that's going to help you on your, your biomatter that you're measuring. But if that could be of use to you, I would like to at some point put you on our dashboard link so that you could see some of that data.
Absolutely, would definitely appreciate that. And Lucy, if you're on, I hate to even ask you, could you capture that data? Because I'm going to forget in about 10 seconds. Thank you for the comments, and yes, I would definitely like to have that.
I'm about
Yeah,
to put,
I'll put my email in the chat so you can contact me that way, and I'll send you the link.
Patrick, if it's okay, I'm going to go ahead and email you for that link.
Perfect, thank you.
So now we're in Galveston, Harrison, Jefferson. Orient you a little bit to Galveston County, because we're going to dig in just a little bit. So earlier in the bookend, Jefferson, Searim State Park up there. We have Bolivar Peninsula here. And then we have northern tip of Galveston Island. We have the seawall here. And then we go to the west end off of the seawall. And then there's San Luis Pass over here. A little bit of a mixed bag. Okay, now we're looking at data a little bit different. It takes a second to kind of to grasp this one. So let me just explain what we're looking at. It's actually kind of cool once you get it. Okay, picture the coastline of the state of Texas. Okay, this is the coastline. This is the southern tip. Moving to the kind of northeastern tip along the coast, Jefferson County. And so what this is all the data brought together with percent exceedances aggregated at each individual site. So where we at? Cameron County. This is that Boca Chica blip that we talked about just a second. Cameron County, Cameron County, Cameron County. Clayburgh. Okay, what's the other line? Oh, this is the maximum. Okay, real quick. The lowest level we can collect is 5 colonies per 100. The maximum we can collect is 24,196, which is a very high amount. And so if you're capturing the high end, you're talking about a very extreme concentration. So now as you look both at the maximum value, wow, look at this. This is just hugging, when you look at the aggregates by site, this is hugging near zero. So excellent water quality for fecal indicator bacteria. Moving to Clayburgh, a little bit different mixed story here for Nueces County. Nueces, I'm thinking this is going to be our Colrose Punish. And then we're moving across Nueces, and then we start moving into San Pat, Matagorda, Brazoria, Galveston, and we move over to Jefferson. So you look at it all together, you see that it's quite a diverse ecosystem of data when we look at all of these. So back to the wonderful question, what's your name?
Remy.
Remy?
Yeah.
Cool name, Remy. Back to Remy's question, what are the drivers? Yeah, that's like the golden question today. We're going to start driving into that a little bit more. Some more slides from Gabriele. Okay, just going to pause on here. These are some crazy slides. You heard the thing, a picture worth 1,000 words. Well, this is a picture with 1,000 words on it. So we're just going to focus on a couple of key things. We're going to talk Galveston Island for a few minutes. Okay, we're going to talk Galveston Island for a few minutes. So back to the question on the drivers. So here we are. If you collect the data, you hold the bag of, whether it's a good bag or a bad bag of, if you collect the data, you hold the bag. Okay, that's how it works. You hold the bag. Okay, so at Texas Beach Watch, at General Land Office, if there are a bunch of issues in an area, who do they ask? They ask the person holding the bag. Okay? Anybody ever held a bag of? You have a dog you have, and what's the first thing you want to do with it? Get rid of it. Yeah, you want to throw it in the trash. Well, we're talking about coastal water quality. What is the journey of a particle when you go down and you collect it? What is that journey? We have no idea. We don't have a clue. Okay? So a number of years ago, what set the stage was in 2019, we had an excessive bacteria event that spanned 60 miles in 2 counties. It lasted over an entire summer. Most of it was in a dry weather event. These were impacting people's wallets. These were impacting people's livelihoods. We were getting calls, a lot of calls. Speaker's off right there, but. So. After this event, I got a phone call from a gentleman from the Houston Surfside area. And he proceeded to tell me a story. And he started by introducing himself. And he said he's a surfer. And he told me that he was surfing out on past the 3rd sandbar in Surfside. And he caught the faintest whiff of sewage. Just like the faintest whiff. He's like, I smell it, but I just dismissed it. It's like, there's no way there's sewage out here. Then he told me 3 days later, he was in the hospital. They couldn't find out what was wrong with him. They gave him spinal taps. They pumped him full of all kinds of different drugs, trying to alleviate an infection. He almost had full sepsis and almost died. He was there for 6 weeks. He lost 30 pounds of muscle mass. And he called me shortly after getting out of the hospital and wanting to share his story. Of course, how do you connect all these dots? We do a million things. You get sick right now. Well, was it breakfast this morning? Was it something you touched on the door? Was it whatever? You know, there's a million ways and this stuff transfers. Well, he told me this story, and I'm not kidding you. I just had like shivers. And we get these kinds of calls. Sometimes it's from the daughter who wants to take her elderly grandfather who has diabetes and is immunocompromised and wants to go to a clean beach where they can go and not worry about getting sick. So there's a lot of things that motivate me, but when I hear these kind of stories, I mean, I go into overdrive. This is the kind of stuff that really does hit home. This isn't just like it's work, of course. It's not just academic, but he called after this event. There's a lot. I'm going to unpack that more. This is called foreshadowing in a book. I'm going to unpack that more. But when it comes to drivers, there's so many confounding things, Remy, that are difficult to piece together. And that's what we're trying to do. And this is teeing up my question for you all here in just a few minutes. We are on a quest and a journey to figure this stuff out. We are employing a lot of different techniques and strategies. I'm going to share one of them with you. And first piece of this is, how does the water interact with the land? And this is gonna be hard to see. This is so hard to see. I'm not even trying to mess with my computer because I'm just gonna mess things up. But I'll share this with y'all. Y'all do see light lines and dark lines. I think you can see light lines and dark lines, I hope. So we asked the team at Texas A&M College Station, we asked them to delineate where they're not even watersheds, right? A watershed's kind of a landmass, everything drains to a specific point, and then it moves downstream and it discharges. These are more like micro pore sheds. These are areas where water sloughs off. When you walk to the beach, you park somewhere, maybe we're gonna pretend like you're parking off the beach. You walk. You might climb a dune or go over a dune walkover, then you go back down, and then you go on the beach, right? So water that typically drains to the beach in Texas, in most cases, the only thing that's draining to the beach in many cases is what lands on the top of that dune and then drains toward the beach. There's exceptions where you have a neighborhood that drains off and eventually that storm drain makes its way down to the beach. We implemented policies many years ago. This is a shining example of a policy that has brought many benefits, which is there's a prohibition from discharging to the Gulf. Not a prohibition to discharging to the bay, but to the Gulf. And so often what this has resulted in is that when we talk about driving forces and you look at a hydrograph and pollution loading that is very standard across almost any water body, we all know what a hydrograph is, right? We have base flow of a river. We're going to do a river hydrograph. Boom, we get a lot of rain. And then it goes up, and it peaks, and then it falls. That fall might be different depending on where you're at. Well, often in a hydrograph, you have base flow, and then you have this upland, the up curve here. That is where the pollutants, that first flush occurs. You often have concentrations of contaminants in that first flush. It might dilute at the peak. You might have a dilution effect, dilute, contaminants reduce, and then eventually you get down to base flow and contaminant base again. So it's not always that way, but that is a very standard thing that happens in many cases. That's a general way of approaching how stormwater impacts a water body. With Beach Watch, I'm going to talk specific to Gulf, okay? We have very few instances in which we can detect contaminant loading associated with the massive rainfall. It happens, of course. Rain impacts water quality, no argument. But are we detecting it when we sample on our routine schedules? When we're out there, we do a little bit statistically. You'll see it'll tease out. There was not in this data set here, there was not a strong relationship with rainfall and increased bacteria, but there was with some other stuff, which is kind of interesting. So when it comes to applying watershed sciences to Gulf beachfront area, something that I learned real quick when I first took on the studio, because I cut my teeth in upland freshwater. That's where I did all my work for 15, 20 years, was in upland freshwater. And then I started to figure out this coastal stuff. And I was like, holy cow, I've got to throw out everything I know. I've just got to empty the bucket, throw it right out, and then start new. A couple lessons I've learned is if you learn something in one area, you probably can't apply it to the next area. It's hard to find patterns. This is another teaser for you guys. How can we identify patterns that repeat, that gives us insights to how land use and is impacting water quality? Where are these patterns occurring? Why did they occur? If you try to apply somewhere else as a lesson learned in generality, I have found that all it does is make you, what is that old saying about assumptions? Okay, so it really does play out. Trailing off. Okay, so back to the techniques we're applying to learn an insight to Remy's point. What are the drivers? Most of the water drains bayside or to this side of the island or back over here. So we have very little runoff moving straight to the Gulf side where our monitoring sites are. Okay, the researchers divided the island into 3 areas: west end, seawall, and east end. These are distinct geographic regions that the land use is different and distinct. Okay, so we're showing a lot of red and yellow on these other graphs, but in my opinion, the water quality picture is actually, it's not an ugly picture. It's actually quite the opposite. It's actually pretty darn decent. water quality when it comes to contact recreation fecal indicator bacteria. It's not bad. Is it that way everywhere? No. So what we ask is, can you use data analytics to decipher and find areas that are distinct from other areas? Let the data tell us, okay? Was this distinction, we're talking about it like, okay, everywhere on the site has really low numbers on the island. I'm just gonna make this up. The geo mean, we use geometric mean as an indicator because it compresses the high end, because most of the data are fairly low in numbers, talking 10s, 20s, 30s, but then we get these crazy ones that are 24,000. And so we use a geo mean to give us insight as to what is a typical or average value. So we use GeoMean to compress that data set. And so we ask, and this is percent exceedance data set here, by the way, which sites are standing out from the others, okay? So in this analysis was very interesting because it identified this little spit right here on the seawall in this area bayside of the island. So quick hint, none of these were impaired for contact recreation based on the TCQ. But the island does have advisories posted. It's just part of Mother Nature. Comes from warm-blooded mammals. It comes from Mother Nature. We're talking seagulls, coyotes, dogs, cats, and everything in between, of course, people. And so this identified a few areas that distinguish themselves being different. We did look at sea level and see if there were impacts as well. There's too much here to really talk on. We looked at relationship to rainfall, and there are some increasing findings of interest, but nothing that drove us to any particular direction regarding decision making. This is talking about some trends associated with rainfall. So there is some relationship here. It's fairly weak. To answer the rainfall thing, we need a specific study. We need a rainfall study, and not to try to apply the beach watch model to answer rainfall questions. You're trying to do too much with the data, probably. Just my guess. We looked at the records for, is there a wastewater treatment plant that is busting its limits and what it's supposed to be discharging, to see, can we connect the dots? If there's a discharger, see, I think that might be on the next slide. Yeah, if there are dischargers on the backside, these dots up here are discharge locations and or the sanitary sewer. Can we connect the dots from something that's done bayside? How does that water move around bayside, whip around the island, and then get into the front where we're sampling it? Good, easy question to ask, hard one to answer. Of course, we look at on-site septic systems as well. I have phantom bonus points to award. Anybody can guess the approximate number of septic systems in the coastal zone, just like by tens of thousands. Phantom bonus points are big. 50, oh, killing me. What's your name?
Mahima.
Rahima? Mahima. Mahima is like, it is very good. It's like 57,000 septic systems in the coastal zone. So like, if this price is right, like nobody would have been able to beat that guess right there. There's a lot. So how are these contributing to our water quality? So fast forward. Oh, and okay, this was a really cool one here. Hotel occupancy tax, hot. It's collected everywhere. You stay at a hotel, like you pay the $99 rate. Like if you go to a beach, but then like you end up paying like $140, right? Or $150. You're like, wow, that's a lot of tax. Well, some of it goes to beach maintenance, maybe. There's also something that's called hotel occupancy tax. That goes to the comptroller. They give some of it back to the local jurisdiction to help them with beach related services. And some of that also goes to the state and is dispersed in other ways. We actually build beaches with some of that hot tax. But here's the cool thing about hot tax is it's not exactly readily available, but you can get it. And so what does hot tax do for us? It gives us insights about visitation. We have more hot tax, you have more visitation. So, let me see what's up next. Let's see. I'm trying to just decipher here through time, and I know we have limited time. Long story short. Okay. I didn't talk about this when it comes to the big data sets. This is the 10-year data sets, 80,000. We have peaks in the data set that have proven themselves to be statistically and significantly higher. We have peaks in bacteria in March, June, July, September. They pulled up, and different researchers have identified the same sets of peaks in bacteria. And then we have collaborating or corroborating data into the A&M researchers, the College Station. Lo and behold, they coupled Enterococcus and hotel occupancy tax and found that they are related together, positive relationship. This relationship was found to be significant in several areas, predominantly on the seawall. But again, this isn't a uniform data set. It's simply not uniform. If it was, we'd have it everywhere. It's like, okay, there's some hotels here, then there's an academy and a grocery store, then there's hotels here, and then there's Airbnbs everywhere. So this is also giving us insights. I didn't tell you about one key thing about bacteria, and this is what makes it a real, I call it fickle. So if you're measuring pH, hydrogen ion concentrations, if you're measuring nitrogen, if you're measuring, well, I'm going to say temperature, you find that they're uniformly distributed. So if we have this water body here, and I want to measure pH, and I can go here and measure pH, I can measure it all the way down, and I bet that pH all the way down this whole area is going to be pretty darn uniform, if not perfectly uniform. But if we went out as a class experiment and we all took those 125 ml bottles and we gathered around together, even if we got in a circle, kind of a decent sized circle, and we all sampled at the exact same time, our results would probably be drastically different. And that is the real booger about holding the bag, is that fecal indicator bacteria, Enterococcus, they adsorb to particles. Sometimes they float, sometimes they sink, sometimes they stay suspended, sometimes the light kills them, sometimes they reproduce in the sand. There's new sources coming and going all the time. So it's a fickle, we all have those friends. Sometimes they're unpredictable. And that's like our buddy Enterococcus. Okay, so, all right, we're gonna pick the story back up. We hired College Station to do this work for us. We have this mission of reducing bacteria advisories. Found some hot spots. Okay, what did we do? What did we do, Lucy? We got bicycles, rode around the island. So often I'm waiting for the big voice from the sky to come down on me, but so you've heard of the saying, needle in the haystack? With bacteria work on the coast, you have to find the haystack first. So that data analysis helped us to find potential haystacks. Was there a needle in the haystack? We don't know. Could it have been data anomalies? Could have been, you know, things aren't perfect. Data is not perfect. Analysis isn't perfect. But we went around and rode on our bicycles, drove around, and we found something that's kind of awkward. I really have it set up. I look at Google Earth to do some other things, but I think just for the sake of timeliness here and conversation, because oh my gosh, I need to speed up. We found a small trickle of water. It was maybe a half gallon a minute coming out of a storm drain. I looked at Google Earth. You can do the reverse. You can look back in time, and that water is moving across a sidewalk at a very popular beach. And you could see the biofouling of that water line on the concrete. It was algae and other just biofoul, let's just call it that, 10 years. That water had been moving across that sidewalk, maybe consistently or intermittently for 10 years, because you can see the signature on that. All right, so we go, we start collecting samples there. Holy cow, they were hot. We found what we thought could be sewage. Hot, 10,000, 15,000, 20,000, over the limit. So they're hitting the beach here, and then you can see scarp, and then they're moving into the water here. And so one day when I was out there taking a video, there was a romantic couple in the background getting some photographs taken. They looked like maybe they were engagement photos or something. Well, they had their feet in that water. And I started going, how many kids have played in that water? If I were a kid, I would have been in that all day long as a kid. But it's not like you think you would smell it. You would think you would be able to know right away. But if it's going through ground and it's being filtered out through the sand, you don't necessarily can see it know it when you see it. So long story short, because we need to move on. We began developing relationships with the city of Galveston. The utilities department was incredibly impressive. We worked together to, here's the site here. This is what I was talking about. Here's the site. And this was where this is a long story, but just to cut through it, we collected a lot of additional samples. I had to get a lot of data before I wanted to activate another team. It's a big deal. You put a lot of capital on the line. You can cry wolf and they'll never pay attention to you again. So, but they resourced an entire crew. We went out, collected samples up and down this conveyance channel to try to figure out where the source was. We never did figure it out in this site run. They had to do smoke testing. We're still in the problem resolution phase, but data analytics can lead to finding problems if you know what questions to ask the data. This is what some of the manholes look like. This was this is the storm drain during dry weather should not have water in it, and we're finding sewage and what we think is probable sewage. Okay. We had program resources to work. This is Clean Coast, Texas. This is a big program we have at General Land Office. We're investing big in improving water quality and working with communities. Okay. Let me switch real quick. One other graphic. If anyone has questions or comments, this is a great time to share them. Yes, sir.
So I keep thinking about that Matagorda situation. Surely that has to do with some sort of agricultural or I'm thinking cattle in particular as a source there. There's just not enough people there.
Yeah, that's a great point and a great tee-up segue to the next part of our discussion here. And now we're drilling into the question and points of interest, and I am going to do a little manipulation here. And we're gonna have to zoom in quite a bit on this. Great question. So the question was I believe everybody probably could have heard it, but it was about there's a lot of agriculture and not a lot of diverse land use. So I am going to go back to that instance that I mentioned a second ago, and I might zoom in another notch. So please forgive me for not really knowing exactly how to tap into your projects, but what I'm going to do is there are a couple of very specific instances in which have confounded us. We don't have answers. This one is related to the 2019 June, July, August high levels of bacteria. They had advisories posted. All of Matagorda County, all of Brazoria County, about 26 sampling stations, all the way from San Luis Pass, which is right at the edge of Galveston Island, all the way down to Colorado River, which is what we're seeing here. So the question is, why did we see the elevated bacteria more or less very consistent through a dry weather pattern time period at those 60 miles of sampling sites? That summer was preceded by a very wet spring, not just in the coast, but also central Texas. We had a very wet spring, all the way up and down, which meant the rivers were pumping, the main stems were just, and they were just rocking, bringing a lot of water down to the coast. All of our local streams, they were moving and grooving as well. But we started to observe this, and it was across the counties, and we're like, okay, what is happening here? So what's the first thing we do as a practitioner of the program? Okay, it's raining a lot. It's raining. Raining's driving this. Look at, is there perfect radar coverage of rain, by the way? No, it's pretty spotty. It's pretty difficult to determine rain mounts, especially in some of these smaller areas. We don't have the best rainfall data, but we start looking at everything that we can go to. TexMesonet, Water Development Board run site, has a great cache of precipitation data. If you're looking at TexMesonet, did not see big rain events across both of those counties. Okay, it's got to be, wow, what is going on? It's a major system. It's a major wastewater system that is like, it's millions of gallons a day, and it is got to be what is going on. So we started making cold calls. Hey, hey, look, I'm not regulatory. I work with the General Land Office. This is just an informational call. I'm just looking for information. I know we don't know each other, but by chance y'all having a major upset. You know, first off, it's really difficult to make that call. Think about it. If you're running this thing and you have regulatory oversight, we don't do regulatory. Made like 20 of those calls, looked at every treatment plant. I didn't know at that time I was flying blind. But I can tell you right now, we have 255 treatment plants in the coastal zone, 255. So we know something about the performance of those treatment plants. So by coincidence, I'm just going to say it, the village of Surfside was amidst an issue with their waste treatment. They don't treat on site. They pump their waste upland to a treatment plant where they do it. They have this interesting vacuum system in which it's a sump in which multiple houses are connected to one box. When it fills up, it literally like vacuums the waste across the bridge through pipes all the way up to the treatment plant. Well, they ended up, and this is crazy, this is 2019, they had 204 malfunctioning sump boxes. And this was real stuff. Like you know it when you see it, you know it when you smell it. Like it was like the full meal deal, Hershey bars and toilet paper, the whole thing. And we're like, oh, it's Surfside. It's Surfside. It's gotta be Surfside. We found it. We know the source. Wait a minute. How would it go from Surfside, Texas, all the way down? And I'm sorry if you don't know the geography. It's like 20, 30, 40 miles. It could be 60 miles. It's somewhere in that range. How could it emanate? First off, how's it getting to the Gulf water? You don't see it crossing the beach. We would see that in a jiffy. Someone would tell us right away. How's it getting there? Wow, okay, it's Surfside. Is it Surfside? All right, so that teed up a separate question of how do we begin to get understanding to how can a particle move from one location to another location? How could it move 20 miles, 30 miles, 40 miles? And let's see if I can actually pull this up and run a quick video of All right, here we go. See if I can get this up and running and share it. Give me a sec. Tell me, how bad am I doing on time?
There's still some time. 20 minutes.
So we first started looking at some available data that is being modeled along the coastline to see where water is moving. Let's see if I can even orient myself to this thing so I can explain it to you. Okay. We have the Colorado down here, Matagorda, then we have Brazoria, and then that's Galveston Island on the top right. So we wanted to get some ideas, and this is Surfside, this is Freeport right here, this is Surfside. Okay, so if Surfside was the source, and these are the movements of water, that's kind of like, can a contaminant move against the grade? Osmotic properties, perhaps, if it's salt, but it's not going to do this. It's not going to move against that grade. So what we started doing was to work with the Water Development Board, and I'm going to be too clunky if I've got some other models and animations that I can show, but I want to progress kind of quickly here. We started using oil spill models that they use for, we got oil spill, GLO, one of our responsibilities is oil spill response. And so we have some pretty darn good models that have proven out. So we chose a petroleum product that we thought best mimic the behavior of bacteria. And so we found something that might float near the surface. There's higher concentrations of bacteria often found at the surface because they adhere to the water properties, and sometimes they're higher in concentration. And so we found one that would not be floating at the top, nor would it sink. They would be in that upper part of the water column. And so we started doing these models specific to July 3rd, 2019 for about 10 days. And I can't find a specific one right there. We chose July 3rd for about 10 days because it was completely dry. So we knew that we could kind of throw out any idea of it being a rain event. This was also in the middle of our event. We call it FibCon, Fecal Indicator Bacteria Contamination. FibCon is our vernacular around the office. And FibCon has a signature. It's happened multiple times, usually without rainfall. We have high values spread over a small region, maybe sometimes a larger region, and we detect what appears to be a fecal indicator bacteria plume that blooms out and then it disappears. So FibCon, we went around, we put contaminants, we modeled contaminants at the Freeport Ship Channel. We modeled contaminants at the GIWW behind the Freeport Ship Channel, behind Surfside. We modeled contaminants Gulf side. We wanted to see what the model would say once they made it Gulf side. What would they do? Would they go one way? Would they go another? In that particular model, they ran up the coast. They were following those currents up towards Galveston. The model showed that they did not make it across San Luis Pass. San Luis Pass acted as a block. And guess what? We had sample sites a half a mile from the other one that was lit up in Surfside. Galveston Island did not experience FibCon at all, but Brazoria and Matagorda was lit up. We went over to San Bernard River. Okay, if you don't know San Bernard, it's discharging from the mainland. It does not have direct access to the Gulf. It has to go down the GIWW, it has to make some lefts and rights, and then eventually it can make it up to the Gulf. So we modeled contaminants there. Nope, they couldn't make it out. Then we went over to another slide I was going to show you, which is we went over to the mouth of the Colorado and we modeled contaminants over there. And give me just a second for my mouth to catch up with what I'm doing. We modeled contaminants. We're like, okay, there's something going on up here. We also tested the main stems. We have the Brazos, huge river system. We tested the Brazos. We did find some very interesting things when we tested the Brazos. We tested the Colorado. None of these had these high concentrations. Then we modeled contaminants down here. What happens when a contaminant enters the Gulf? It spires out like this on both sides. This is a pattern that has repeated itself in numerous models. It does this. And then it will catch the predominant currents. So what we learned from the models was that during that time period, there was no scenario in which a contaminant came from a source, the Brazos, the Freeport, the Colorado, the San Bernard, all of these various areas. So we identified no ability for a single contaminant source to hit our Gulf fronting beaches where we have monitoring sites and then migrate. We did find some cool things though, that we did see that a contaminant could migrate over 12 miles a day and stay concentrated to the Gulf Coast based on the modeling results. That was pretty cool because at the time, no one thought that was even possible as I was having these conversations with water practitioners. So we had some really interesting insights brought from the modeling, but what can we always say about modeling? It gives you insights, you know, these give you good clues about what's going on. Might be right or wrong. Yes, ma'am. Yes.
What other parameters are part of the model? I mean, I know survival, right, and higher temperature, sunlight, pH, and other aspects might have, because I'm thinking how long it takes to be transported, diluted away, but also decaying away.
Yes, great question. Yeah, I mean, not everything that enters the environment stays alive. It sinks down, disappears, there's predation, it's no longer viable for detection. Great question. I do have a point at the very end of this that I will come back to your specific, but it was not accounted for in the modeling we did here with water development, where this was these are oil spill models. We're trying to kind of, you know, do a back of the napkin, kind of get us insights to what's going on. No significant rainfall. Did we find some potential smoking guns? Yes, we did. If that was the Surfside incident, what would we have found? What does distance decay tell us? Y'all know distance decay, right? The phenomenon is going to have more influence in the area in which it emanates from, and that influence is going to dissipate as you move away from that area. So would we expect higher concentrations near that? We couldn't identify that either. Couldn't find an area that was particularly hot. We looked and looked and looked and looked and looked, found nothing until you go, well, using the process of elimination, and this is dangerous, I'll tell you straight up, this is dangerous to do. There's only one other culprit that we could find that could even be reasonably related to it, yet there was no instant of this happening here in Texas. These are little stars right here. Okay. Same little stars. You hear the blue triangles are beach watch sites. What are these stars? These are septic systems. So from the process of elimination, applying the judgment and data that we had, we developed a hypothesis that somehow, after eliminating the other sources that we thought we could count on, because this was a unique phenomenon, which has repeated itself, by the way, last year in 23, the week before Memorial Holiday, repeated itself on Bolivar Peninsula. So we developed this hypothesis that somehow partially treated contaminants were migrating into the water that we were sampling. We had no way to prove it. We certainly weren't making these types of statements public because even to this date, we are still not certain about it. But we are fortunate enough that Dr. Morgalet formed a multidisciplinary team, bringing water chemists, microbiologists looking at source tracking, bacterial source tracking, microbial source tracking, and then studying the interaction between shallow groundwater tables and the nearshore environment. Her work is still ongoing, but has brought us many unique insights that we've started learning from other states, such as Miami-Dade in Florida, that they're actually been observing this similar type of phenomenon. It's been occurring elsewhere as well in North Carolina, where this is the observation, is that these shallow groundwater, they're not static. Sometimes they go up, they sometimes go down. They're impacted by numerous different variables, and that they could be interacting with septic drain fields that rely on dry soil and that biological activity in the microbes to eat and digest the contaminants, and then they disperse into the environment. What we think could be happening is that we have interaction between that shallow groundwater table and the septic drain fields. We do not know for sure. This is a continuing development. The question is, why does it occur? Under what conditions does it occur? What areas are more susceptible than other areas? Why was FibCon in 2019 only in Matagorda and Brazoria? Why was it not observed in Galveston County? We have clues and cues though. We see multiple data sets when they're analyzed. We have peak bacteria in March, June, July, and September that also correlate with occupancy, increases in occupancy. Are there interactions between all of us collectively? It's not non-point source pollution. Not any one of us is a major contributor, but us collectively, can we influence the responsiveness of the water resources? And that, in essence, is the big data question. Dun, dun, dun.
Thank you, Jennifer. Questions?
Question, you have the source tracking data, because if it's septic, you should have human tracers. Well, like in Corpus Christi Bay, we have cases where we can distinguish between human tracers and gulls and dogs and cats. And if it's humans, then it's just strong.
It is, the bacteria source tracking has been in our industry for at least 20 years. It was once heralded as a silver bullet, as bringing a lot of different insights into what's going on. Of course, it gets much more complicated when you try to apply it. I will say this, that we have attempted to use the Texas Beach Watch infrastructure to assist in gaining insights to which species are driving it. In my opinion, as I've seen the results come back to us, we have 3 different microbial source tracking labs bringing us data. It's been a mixed bag, and it's been confounding, and some things are not making sense. Where, for instance, we see a water chemistry signature of wastewater, but the source tracking data do not seem to present anything associated with human. Whereas we see wastewater stream, and even in the ground, we're seeing seagull or canine in more prevalence than we are human. So I'm not a microbiologist. I don't understand the ins and outs, but I do see a confounding set of data that have yet to make sense. But we are changing our methods and strategy and tactics, but we don't have answers yet. But yes, you would think you would think that would be the quick and easy answer to get the source tracking data to the table to help point. But I have yet to see all of the evidence come in to actually gives us actionable results. Yes, sir.
I wanted to maybe try to get a little bit of clarity here in terms of what we have to work with. And so you mentioned you guys had tens of thousands of measurements of, at least enterococci counts. And then maybe some associated water quality parameters, with that. So would that all be data that would be accessible to us?
Absolutely, yeah. We'd be happy to, we can share what data we have that we can query out. So it's gonna probably be at least 14 years of data up to date at this point. And so if you want all of it, we can provide that over to you, no problem. We do have associated field observations as well. Our data management system as of right now is not housed in a manner that it's all accessible, but it's laborious and it's gonna take some programming magic to couple those together, since they're housed in two separate systems with field observations.
Oh, yeah, yeah, that's, supposed to be part of the training to learn how to do this kind of thing, so. Jason, sorry, I think
Oh, yes.
Amanda had a question, so I'll go. No? No? You sure?
Come on.
No, go ahead. You guys are supposed to ask the question, I mean. No? The septic system data set, do you have it or is it the AgriLife extension?
It's AgriLife. We do have it, but just due to our agreement with the use of the data that and actually Gabriele Benanti, who I profiled his data slides, he's a point of contact. And so they're able to share that information back over, but we ask that all queries go direct to them so they can manage their paid exports.
Okay, but it's available.
Yes, it is available.
Septic system. Yeah. Oh, okay. We're still talking about septic systems. Okay.
I don't want to taint you as the answer. There could be a million other answers as well. I mean, it could really be anything. For all we know, it's reproducing in the sand somewhere, in a lot of different somewheres. Maybe it's all brought by the goals, but these interesting patterns, March, June, July, September, and the hotel occupancy tax. It is certainly very interesting that we are starting to see a couple of little patterns. If I can comment on your question about the longevity. So back to on our end, trying to solve problems. Okay, desktop analytics, an easy lift. It's hard, but it's an easier lift. Then we started collecting data. Okay, let's do the source tracking stuff. Let's work collaboratively with all the researchers who want to work with us. That gives us more insights. Then we did the modeling stuff. Okay, we were applying kind of a square peg to a round hole. We did some modeling to try to look for that. A little confounding. So then I started really thinking about this whole thing about hydraulic connectivity. Okay, we have these 255 plants. These sources are so prominent. And they have longevity. It's like, let's rule things out because we know where they are. Let's rule things out. So I started thinking about hydraulic connectivity between these plants and the beachfront. That's like really, really difficult modeling. So what we're in the process of doing right now is forming a partnership with a modeler out of U of H. And what we're doing is we're bringing these worlds together in which her name is Dr. Hanadi Rafai out of U of H. She's done a lot of total maximum daily load modeling for TCEQ, and she does coastal modeling, but she has yet to do Gulf modeling. And so what we're doing is we're joining her modeling with a monitoring team. So she can work on modeling magic, and then we can collect real world data to inform the model and ideally get this model to share with us insights and patterns and things that are repeating to help us understand what's going on with water quality. So we're hoping that this modeling project that we're still working on the scope and to get this together, that will help us to decipher some of these more complex hydraulic connectivity questions.
The sewage data, the wastewater treatment plant, are those available, publicly available, or is something that would be requested and
So we sought that information and data from the TCEQ who provided it. It is, let's just say it was difficult. I had a lot of questions to ask that data, but some things became apparent that the data didn't seem to be whole. And part of the way it's managed is that it's unauthorized discharges and sanitary sewer overflows. So an SSO is like a manhole that overflows. And an authorized discharge is a contaminant that's outside of the accepted threshold from a treatment plant. Those are combined into one data management system. So it's, and then the reporting framework, it's a difficult data set to work with. I found it to be, but maybe if you have someone it's not a troglodyte trying to operate the data, then y'all might be able to find some better answers out of it.
We're gonna try, right? Because we need that information. So with Roya's magic, I think we can achieve some of those. That would be easier for the group too. But we'll reach out to you if you don't mind to get us started.
Absolutely.
Question and sort of, so I know pretty well the Corpus Christi Bay, sort of either having modeled or being part of the stakeholders. And at least in Corpus Christi Bay, it's critical, I think, in the modeling sense to split the precipitation-driven bacteria versus the dry weather. And then in terms of big data, then the rain precipitation data becomes, and precipitation data can influence for different kind of point of time depending on the watersheds. Do you have a precipitation data set? Do you know if MPE or MRMS works better? If they were to tackle that and take on the precipitation, do you have, I know for things that have worked in Corpus Christi, but in general, do you have advice on what to do with precipitation?
We, as far as finding data to bring in, incorporate.
What's been used? I just know for Corpus Christi Bay. I know it needs to be high res, both temporal and spatial, but I don't know. And we've used MPE, there's MRMS now, and there may be other sources of precip.
So from my perspective, like readily available data for the coast is, I usually go to TexMesonet.
Okay.
That's the Water Development Board. And they have a compilation of sites, and then you can actually query out historical data from there. And they have good customer service in that you can ask them, you can tell them what you want, and they can even query it out for you.
Oh, cool.
Once you learn their query mechanisms, it's a little bit awkward at first, but then you can get in, you can query specific data sets from specific stations. But the difficulty comes when you have a station over here, but you're interested in another location, and then you might have to collect several and then hope, unless you have some of these other sites that can extrapolate in between and give you that type of data.
If it's a big watershed, so would an advice for them is to pick a small watershed first, or you want them to solve all the problems?
Well, you also have, like, if you have USGS gauge stations or local river authority gauge stations, you can couple those things together as well. So once you start to understand what base flow conditions are, and if it's a larger data set, then you can start to see, you have to understand base flow and then see if you see response from rainfall in the base flow based on USGS, of course, your local Nueces River Authority, Lower Colorado River Authority. There are a lot of different sets of gauging gauge stations that give you that data. So you can even kind of, you can couple those together to see, well, was that a big enough rain that it actually caused any kind of a knowledgeable bump? But to even understand that, you have to study the data from the gauge stations as well, be familiar with what is base flow.
Could satellite precipitation measurements be of use, or are you specifically looking for like ground based? Because the data set I worked with uses things like probably millions of radar defined data from the GPM and TRIM satellites, and it contains just snapshots of individual storms and rain events. And could that be of use to possibly co-locate some of these site locations with these rain events?
Absolutely, yes, sir. Yeah, you all have access to a lot of data, the same stuff I have access, but your world is much more in depth. And I would say, yes, if you have that data, explore it and teach us.
I can confirm for CC Bay, you can correlate the satellite or the MPE or MRMS, the different products, with either the Naval Air Station or the airport, and that works very well. While keeping in mind that the airport and Naval Air Station are quite different when it comes to precipitation. It can rain, well, as you well know. It can rain somewhere in the, in parts of town. It's not gonna rain in other parts. And if it's quite local for the bacteria, that makes a huge difference. So you need high res, both temporal and spatial.
We do not have enough rain gauge station for part of our counties. That's why it's better to just use GPM data set, especially 3 image radar data set. And we are working on that, and hopefully we can find something, some correlation between these parameters we have. And it's the best IVIT we can use that radar data set.
The other data sets related to modeled salinity. These are big data sets that TABS buoy and the GERG out of Texas A&M College Station. I'm sorry, I don't know all the acronyms right offhand, but you can get salinity modeled, water temperature modeled data. That one with the arrows I was showing, that was just straight off of a website over a particular time period. So you can get all of this modeled information for our coastal zone. It's just a matter of like, where was the nearest data point and how did it derive a data point over here? You want to understand that. Of course, they might be extrapolated between the other data point here. But there's quite a bit of other data as well, just to show you wind and water patterns for where the water is moving along the coast that is also readily available. If you find turbidity, let me know. Turbidity is if we had readily available turbidity data, as bacteria is known to be correlated very closely with turbidity, higher turbidity often. You have bacteria that can track along with that. It's not always the case, but it would be a great one to have.
Should be in part correlated with wind for resuspension.
Right, yeah.
If it's there, that's the problem, right? Because we're talking about tax occupancy, right? There are times you have people there and then at times you don't have people there, but your wind is going to be, the patterns are going to be there. So it's just how many times you're going to find it with the wind because the people are not there to supply the bacteria, right?
September is the less windy months. It's funny that you don't have August in your high.
Interesting, right?
Yeah, would think that August should be part of it too. March for spring break, and then June, July. Why not August?
We need to ask the data. What and why did Cameron County? Why is it different? Why is Jefferson different? There's a lot of questions. Yeah, I mean,
less surprising, I would say.
Right? Yeah. We need to look at land use and setbacks off the beach and local infrastructure. Well, I'm available for follow-ups later down the line as well. If you have anything you would like to follow up with, please let me know.
They will work on, together and assess what, the discussion was, the data availability, and they'll put together a kind of a summary report. And then we'll go back and forward about what is gonna work. So there will be follow-up questions from us and an interaction with you, absolutely. So we appreciate the time you put into this and very engaging and energizing. So thank you very much. And you guys are dismissed. I know you all have classes to go. If you have to stick around, you want to stick around a little bit more, that's up to you, but just know that you need to go and you can go.
Thank you.
Thank you all.